Alright everyone, so this is day 24, and this is our second out of 3 days worth of assemblies learning. So we're going to learn a little bit more about assemblies, get a little more advanced. This kind of stuff should help you with your vice assemblies as well, so the stuff we'll cover today is going to help you. Initially, floating part. So from now on, all the parts, or not all the parts, but the first part you put in should be floated. And what that means is the part's going to come in as fixed. And can you see my mouse? You can. So the part's going to come as this fixed, which is that F right there. And what you want to do is you want to float that part. That's going to make it, because a fixed part is similar to making a point fixed in a sketch. You're putting it and locking it into place without actually giving it like any actual place in space. And we float things to allow us to figure out their center of gravities and all that kind of stuff. There's a lot of useful mass properties tools we can do once that part is floated. So we'll float that part, and then we'll mate it to the origin, which puts it in the space. We can then mate some of the planes together to keep it from rotating. We'll look at that later. That's going to help you, for example, the bushing on your vise. You'll mate some planes so that bushing doesn't spin. But use your intuition to decide what axis you should align stuff to. And if it doesn't work out right, then just mate the planes. It's pretty easy to do. You mate them like you're mating two surfaces, except instead of surfaces, they're just planes. Ways to import parts subassemblies. So this is review, but you can insert the components from the Insert Components tab, or from File Explorer, or just dragging from a folder onto the window of your assembly. That's is the easy ways to put it in. Subassembly tips. So we're going to be learning a little about subassemblies. Always make subassemblies flexible. So what that's going to look like is your assembly is going to have this little Tetris piece, and this blue piece is going to be part of the Tetris piece. And that means that your subassembly is fixed in place. And that means that all of the mates you put on that subassembly don't matter. It is just going to be a solid piece, and nothing's going to be able to move properly. So you need to make them flexible. And subassemblies are going to be very important to use when you have multiple parts that are repeated, because it allows you to build the subassembly you want, and then just insert that subassembly multiple times. All right, we can get away from that Incredibles meme now. All right, so having the part be first floated and then aligning it to the origin allows us to figure out center of gravity and other mass properties. This will be the way the CSWA figures out if you're making your assemblies correctly, because you're going to input the center of gravity or the center of mass. So it's useful, but it's also going to be very important on your standardized CSWA exam. Center of mass, center of gravity, same thing. And basically you just go to the Evaluate tab and then click Mass Properties, and it's going to pop all this stuff, very similarly to how it would be in a part. Exploded view. So we covered them again, but we covered them before, we're going to cover them again. Each assembly and subassembly needs its own exploded view. But the caveat to that is that if you have a larger assembly that has subassemblies, you leave the subassemblies collapsed in the larger assembly, because you're going to explode those subassemblies in their own exploded views. And that's going to make sense if you've seen the projects or seen the example of the projects. You have all these subassemblies, and you need to explode them individually. So, collapsing exploded view before you submit the file. It saves us time. Creating a bill of materials. So, you're going to click on Bill of Materials in the Table toolbar, or Insert Tables Bill of Materials, and then select a drawing view to specify the model. That's going to be your exploded view. And then place it in the upper right-hand corner, and then you need to change the part number tab to the part name. That's going to be up here. It's going to say part number, and you're going to choose that to part name. So change that. The description column we don't use, so that can just be deleted. You may use that in industry, though. Be consistent with balloon attachments. What we mean with that is that there are these attachments that you use when making subassemblies, and you can have them be arrows, or you can have them be little lines with little points at the end. None of us care how you do it, whether you prefer points or arrows, but they need to be consistent. So either you need to only use arrows on your whole thing, or only use the points or dots. So just be consistent. Don't mix them up. I don't care which one you use. Just use the same one. Another thing is balloon extension lines should never cross. So this one can't be placed over here and then cross through that too. Each one should be kind of vertical and horizontal as best you can make them, and none of them should cross. So this is going to be the same as you're going to, your balloons with your bill of materials. It's going to just be your exploded view, right? This is one of the great reasons why nothing touches in the exploded view, because you want to be able to label things equally, or you want to, not equally, you want to be able to label them, in a way that is aesthetically pleasing. And again, subassemblies remain collapsed. And so, this number 7, say this was, say this is a subassembly. Number 7 will just be, the motor subassembly, and that'll stay collapsed. And then on a separate page, you'll have the motor subassembly, exploded out, and then you'll have that piece with a bill of materials and such. But this is just a little example, the hoverboard stuff. So each balloon is kind of lined up nicely. They don't go all over the place. They're not closer and further. Everything is neat, and that's what's important with these bill of materials. Talking about assembly tips again. Once you unpack the assembly, right, because you get them as zips, delete the original zip folder. Once you have the normal folder on your desktop, it saves you from submitting the wrong one by accident. Save early, save often, always. Check for interferences and part overlap. There are times when part overlap is okay. Like if a bolt is going into a called out threaded hole, you'll have interferences there, but that's okay. Because, we know. A pack and go must be done, so you need to submit them all as zips. And then again, assemblies don't need to be fully defined. They just need to be fully restrained. Helpful assembly tool is the Move Component tool. So it's under the Assembly tab in the ribbon at the top. And basically it allows you to move components until they create an interference, and then it'll automatically show you that interference. So it allows you to find the maximum distance a part can move, and if it's interfering, all that kind of stuff. So that's just going to help you later on. And now we're going to do our assembly example, so you can jump over to that and take a look.